We're on page 304. Using subtraction to solve equations. Removing the same number of tiles from each side of an equation mat models subtracting the same number from both sides of an equation. The subtraction property of equality: you can subtract the same number from both sides of an equation and the two sides will remain equal. When an equation contains addition, solve by subtracting the same number from both sides. This is the key right here. When an equation contains addition, solve by subtracting the same number from both sides. We're going to do that exact statement right there a couple of times. Okay, let's check it out. Example 1. I'm going to cover this up. Move this down, and we're going to do this statement to solve. Watch how easy this can be. See this statement at the top? I'm going to read it for a third time here. When an equation contains addition, solve by subtracting the same number from both sides. So example 1 says, solve the equation a plus 15 equals 26. Graph the solution on the number line. We're going to do that in a minute. The solution, or the equation, is a plus 15 equals 26. Now, if we think back to our mat when we subtracted, what were we trying to do? We were trying to get x by itself. Well, in this case, we're trying to get a by itself. How do we get a by itself? Well, I have to subtract 15. What would happen if you have 15 and you subtract 15? Well, it would be nothing. 15, this 15 right here, and then take away 15. You'd have nothing. Well, if you have nothing, what's left? Well, just a is left. This a right here is all that's left. In fact, I think I'll put it more like right here. What's 15 minus 15? It's 0. I don't need to write that, though. I don't want to write a plus 0, so I just write a. So what did I do? I got rid of 15. Well, if you subtract 15 from one side of the equation, you have to subtract 15 from the other side of the equation. So 15 minus 15 is nothing. 26 minus 15 is 11. And so what do I think? I think a is equal to 11. And that should make sense, because if I go up here and I take a out and I put in 11, what's 11 plus 15? 11 plus 15 is 26. So what are we doing? When an equation contains addition, see this equation right here? Solve by subtracting the same number from both sides. 15 minus 15 is nothing. 26 minus 15 is 11. So a is equal to 11. Now, if you think about it, that would work with what we did on the previous page. And I'll prove it to you right now. The previous page we had x plus 6 equals 14. And what did we do on the algebra mat? Well, we crossed out 6. That's the same thing as subtracting 6. And we crossed out 6 over here too. And if I do 6 minus 6, I have x is all that's left. And if I do 14 minus 6, I get 8. And if I think 8 is equal to 6, if I put an 8 right here, 8 plus 6 is equal to 14. So that's proof that this strategy at the top of the page works. I'm going to read it for a fourth time, maybe a fifth. When an equation contains addition, solve by subtracting the same number from both sides. So that's how you solve those. Pretty simple, huh? It says graph the solution on a number line. Right here I said a is equal to 11, so we go to 11 and we graph it. That's all we have to do. Cool. How did you decide? Reflect, number 2. How do you decide which number to subtract from both sides? Well, what we want to do is we want to isolate the variable. So what we did, when we had a minus, no, it was plus, a plus 15 is equal to 26, how do I decide what to subtract? I'm trying to get a by itself. So to isolate the variable, I got to get rid of this number right here. So how do you decide which number to subtract from both sides? I'm going to write subtract the number that is being added to the, what's that letter called? It's called a variable. Subtract the number that is being added to the variable. And then actually we should write from both sides of the equation. Awesome answer. I feel really good about that one. Alright, so number 3, your turn. They give us a decimal. That doesn't make it too hard though. Number 3 says solve the equation 5 equals w plus 1.5 and then graph the solution on a number line. Of course they show us something and then try to make it complicated. First thing I would do, you don't have to do this, but you could actually rewrite this from 5 equals w plus 1.5, you could actually rewrite this as, you can switch it around. I'm going to do this. Watch, I'm going to do my arrows right here. I'm going to switch this around. Put w plus 1.5 on the left and 5 on the right. All I did was take my 5, my equals. So basically, I'm taking this right here and putting it over here. W plus 1.5 equals 5. So I'm going to rewrite that to look like this. W plus 1.5 equals 5. I didn't change the problem at all. So what do? I'm going to go reread my own answer here. Subtract the number that is being added to the variable from both sides of the equation. So what's being added to the variable? It's 1.5. So I'm going to subtract 1.5. Now what do I get if I do 1.5 minus 1.5? I get 0, and that's what I want because I want it just to be w. If you subtract 1.5 from this side of the equation, you also have to subtract it from this side of the equation. And it's hard to subtract unless I make this a decimal, so I'm going to make that 5.0. Now I've got 5.0 minus 1.5. I'm going to borrow and make this 10 minus 5 is 5. Since I borrowed, that makes this a 4. 4 minus 1 is 3. The answer is 3.5. And that should actually make sense, because if I go and take this w out and put in 3.5, what's 3.5 plus 1.5? Well, my 3 plus my 1 is 4, but my 0.5 and my 0.5 is another 1. So if I think about it this way, 0.5 and 0.5, that's half each, and 2 of those makes a whole. So that's 1, plus this 1 is 2, plus this 3 is 5. The total is 5. So I'm going to write on my line here, w equals 3.5. But then I have to graph it as well. And I graph that. 3.5 goes exactly between 3 and 4, so it would go right here. So we've got 3.5 and a dot on the number line in between the 3 and the 4. Okay, good job. You're done with page 304.